Welcome to another Chapter 6 video, dealing again with the sampling distribution, and this one's actually now dealing with the probability. This is the actual application. This is where you're going to be using it in your different problems. So, as an example, it says the average age of vehicles registered in the United States is 8 years, which is 96 months. The population standard deviation is 15 months. And we're looking for a probability that the mean, which is an X bar. And we have a sample size of 36. So we have an X distribution. We're needing to do calculations in terms of X bar because it's a probability of an average. If this were normal, then we would be able to say normal. But N is 36, which is sufficiently large to state then that we can use this as a normal. So we can calculate probabilities for those averages using the normal distribution. It has a mean, so the mean of the sampling distribution is also 96. It has a standard deviation, 15. Standard deviation of the sampling distribution is the standard deviation of x over square root of n, 15 over square root of 36, which is 2.5. The question asks for the probability that an average, a mean, an X bar, is between 98 and 100. Not a single vehicle, but the average of those 36. So again, let's do a quick little sketch. There's our 96. And we're looking between 98 and 100. We calculate our z's. It's an X bar minus a mean because we're calculating probabilities of X bars over sigma over square root of n. That's the formula, the way it will be written on the useful formulas table and also the textbook. Just a note, that is also X bar minus the mean of X bar over the standard deviation of X bar. So it's the same Z formula in the sampling distribution. For our example, we've got a 98 minus 96 over 15 over square root of 36. Make sure you're using parentheses. And that is a 0.80. For the second one, same techniques. 100 minus 96 over, and I'm going to use that concept of the 2.5 standard deviation of the sampling distribution, and that's a 1.60. So those are our two z-scores. So going now to the standard normal area, it's the probability that a z-value, a z-score, is between 0.80 and 1.60. When you're between, you have to do that subtraction concept. Probability that z is less than 1.60 minus the probability that z is less than 0.80. And again, you're subtracting the probabilities, not the z-scores. Looking up each of those values, and we will be using the positive z part of the table. So again, a 1.60, 9452, and a 0.80. That's 7881. So 0.9452 minus 0.7881 gives us a score of a 0.1571. Looking at how you would determine this, you have to look in this general area first. We have a distribution. Identify the sampling distribution. Is it normal? If it's not, you can't use it. Then set up and look at the question that's asked. Make it sketch. Calculate your z-scores. Rewrite the probability in the standard normal table. Then calculate using your table. So 7 steps instead of just 6. You've got that first step where you're identifying whether it can be used, then the same steps afterwards. That's calculating probability in the sampling distribution.